Welcome back to my YouTube channel, in which I have started the playlist of data science covering the basic and advanced concepts. Now, the next topic is data preparation. Now, let's discuss what is data preparation. Data preparation in data science refers to the process of cleaning, transforming, and organizing raw data into a structured format that is suitable for analysis and modeling. It involves the following steps. First is data collection, second is data cleaning, third is data transformation, fourth is data reduction, fifth is data splitting, and sixth is data exploration. Now let's discuss these steps one by one. First is data collection, in which the first step is acquiring data, gathering raw data from various sources, for example, database, spreadsheet, APIs, sensors, etc. Second is data integration, combining data from different sources to create a unified dataset. Second is data cleaning, in which the first step is handling missing values, dealing with missing or null values by either removing, imputing, or filling in the missing values. Second is removing duplicates, identifying and eliminating duplicate records to ensure each observation is unique. Third is fixing errors, correcting inconsistencies or errors in the data such as out of range values or incorrect data type. Fourth is filtering outliers, identifying and handling outliers that might distort analysis or modeling. Third is data exploration, statistical analysis, understanding the distribution and central tendency and spread of the data. Second is visualization, using plots and graphs to visually inspect the data and identify patterns, trends, and anomalies. The next step is data transformation, in which the first step is normalization standardization, which means scaling numeric values to a standard range which can improve model performance. For example, min-max scaling, z-score normalization. Second is encoding categorical variables, converting categorical data into numerical formats using methods like one-hot encoding or label encoding. Third is feature engineering, creating new variables or features from existing ones to provide additional predictive power or insights. Fourth is aggregating data, summarizing or combining data to derive new metrics or group information. Now next is data reduction. First process in this section is feature selection, choosing the most relevant features, for example, columns for the analysis or model to reduce. Second is dimension reduction. Techniques like principal component analysis or TSNE can reduce the number of features without losing too much information, simplifying models and speeding up computation. Now let's discuss how to add index field, how to change preceding field values, how to re-expressing categorical field values, how to summarize numeric fields, and how to identify outliers. Instead of with theory, let's go with the practical part. Now, how to add an index field using Python. For doing this, I have imported pandas package with the alias name PD. I have provided data, sample data from a dictionary. In order to read data in data frame format, I have used the syntax pd.dataframe and storing the result in data variable. In order to add an index field as a new column, I have used syntax data.index. Here I am adding +1 so that I can start index with 1 instead of 0 and storing the result in data index p. And at last I am printing the result. Second is how to change preceding field use values using Python. In order to perform this, I have imported package pandas as pd name as alias in pd. In order to read data in form of CSV file, that is common separated values, I have used the format pd.read CSV and storing the result in df. In order to inspect data to know which part of data performs which function, I have inspected the data by using head function. In order to identify and handle misleading values, I have used the function apply and using lambda function, which is an anonymous function without function name and syntax we can see. In order to fill out none values in the age column with the median age, I have used fill none function passing the parameters median age comma in place with a true boolean value. In order to remove rows with invalid ages function or values, I have used if else statements and combining them with the AND operator. And at last, in order to show or save the clean data back to the CSV, I have used the format def to CSV updated data.csv and passing the boolean value false. Now let's discuss how to re-express critical field values using Python. First, we have to import pandas package as pd alias name. And in order to read data in the form of CSV file, I have used pd.read.csv, comma split values. In order to inspect which is the current categories and status, I have used the function def status.unique, which will tell us the unique categories present in status. In order to re-express categories using dictionary, we can either use replace method or can use map method. I have used replace method, in which I am passing dictionary with key values active and active pending and the values in 102. You can also use map function for doing the same task. And in order to save the updated data set in the form of CSV file, I have used df.toCSV, in which I am passing updated data.csv and index boolean value false. In order to check the updated categories, we can use df.unique, which will tell us the unique categories present in the data. Last, in order to standardize numeric fields using Python, we have to use pandas package as pd name alias. From sklearn preprocessing, I have to import standard scaler. In order to read data in form of CSV file, we have to use pd.readCSV method, which will tell us the data form of CSV. And in order to find numeric columns in a dataset, I have to use def.selectType data type dtype method that will store the result in the numeric columns variable. And then we have to standard scalar initialization, in which we will store the result in scalar variable. And then in order to apply the scalar, I have used scalar.fitTransform method, passing numeric columns as a parameter and storing the result in df numeric columns. In order to verify standardization, I have used numeric columns.describe method, which perform the task. At last, in order to save the updated dataset to new CSV file, I have used the method def.toCSV, standardized data CSV, and passing the index field value false. Last, how to identify outliers using Python. First, import required packages like NumPy, Pandas, Matplotlib, SciPy, and you can also import isolation forest from sklearn.assemble. I have provided it sample data in the form of dictionary, as you can see on the screen. In order to create data frame or to read data in the form of data frame, I have used the syntax pt.dataframe, in which I am passing the data. In order to display initial values of the data frame, I have used printf functions, in which I am passing the message. Second, in order to visualize outliers using boxplot, we will use boxplot method, and in order to display title by passing message, that is boxplot for identifying outliers, we perform the same task as shown on the screen. Next, in order to identify outliers, we can use different methods. I have used zscope, in which I have used ABS method, which will use stats.zscore method to perform the task and store the result in zscores variable. First, we will set threshold for zscore, that is 3, and if zscore of outlier is greater than threshold, then it will be initialized in outliers underscore z variable. In order to display the rows with outliers, I have used var function and ilog functions. In order to show z-square outliers, I have printed the value and message outliers identified by z-score method. You can also use various methods such as IQR and much more. At last, in order to print the identified outliers with all the methods, we can display the message all outliers identified using all methods, and at last we can print the outliers. Thank you for listening me patiently. Have a nice day ahead.